Greetings! Another beautiful Falcon 9 launch Saturday evening from Pad 39A, marking two unique milestones. The first Falcon 9 to complete 14 flights to orbit and the first 5-burn mission. Elon Musk tweeted, quote, "No obvious limit to rocket reflight so far," unquote. It was the 150th consecutive successful Falcon launch, the 60th lofting primarily Starlink satellites, and the 41st launch for 2022. AST SpaceMobile's Blue Walker 3 prototype satellite was placed into its own orbit, with the goal of demonstrating cellular connectivity around the world using its massive 693-square-foot antenna array. It is believed to be the largest commercial antenna placed into orbit. Several weeks of preparation will precede the deployment of the array. If the testing is successful, the company hopes to start building out a constellation of over 100 satellites, beginning with 5 operational satellites next year. Sunday's planned Starlink launch has been pushed back to Tuesday the 13th. The Falcon 9 had a successful static fire at Pad 40. The instantaneous launch window is at 10:10 p.m. Eastern, with a backup opportunity on Wednesday at 9:48 p.m. The first stage booster supporting this mission previously launched CRS-22, Crew 3, Turksat 5B, Crew 4, and CRS-25. Following stage separation, the first stage will land on the Just Read the Instructions drone ship, which will be stationed in the Atlantic Ocean. Dr. Lori Leshin, director of the Jet Propulsion Laboratory since May of this year, has tweeted about some spectacular prototype transformer rovers under development at JPL and Caltech. A short video shows a quadcopter turning into a rover. Dr. Leshin is a geochemist and continues to be a co-investigator for 2 instruments on the Curiosity rover. At the latest meeting of the NASA Advisory Council, or NAC, the chairman of the Human Exploration and Operations Committee, Wayne Hale, presented the findings of their report. He included many interesting and informative insights into the exploration program. Mr. Hale needs no introduction to longtime NASA observers, having served as a propulsion engineer, JSC Shuttle Flight Director, and Shuttle Program Manager before retiring from NASA in 2010. His straightforward and honest dialogue with the media during shuttle briefings made him a popular NASA spokesperson. In addition to his consultations with NASA, he currently works for a Colorado-based space firm, Special Aerospace Services, SAS.
Artemis 2 will be the first crewed flight, and I don't want to be responsible for putting dates, but I wanted to give folks kind of a feel. I think we're looking at 2024 for that first crew flight. It will be a lunar flyby without an orbit, without a landing. Again, it's in many ways largely an engineering test, but it does have significant science objectives. Next up is the human lunar spacecraft, the SpaceX, the lander. I would remind you, looking back at history, that in the Apollo program, the long pole in the tent, the critical path to landing people on the moon, was developing the lunar module. Developing this lunar lander is very complex. The contract award went to SpaceX. They really are on contract, as I understand it, for 2 events. First of all, an uncrewed lunar landing all by themselves, and I said approximately 2024. Again, don't take these dates as cast in concrete. And then Artemis 3 will utilize that lander and the Orion, and they will rendezvous at lunar orbit, and there will be a demonstration landing of that lander with 2 crew and a short stay, 6 days, I think. And then there is plans, and we can talk about that a little bit more, about the sustained lunar lander capability, because this initial lunar lander doesn't have all the features that NASA wants for long-term operations. So SpaceX will be improving that vehicle, and there's also a competition for a second provider of a lunar lander, which we'll talk about in a little bit. Gateway which is a critical part of the whole program. And I'll talk a little bit about that. Starts, it gets together in 2026 in lunar orbit, becomes the rally point, the logistics node, whatever you want to call it for lunar operations, and then regular sustained human presence following. And I've got a chart on the next page. And then having learned and gained what we know from the lunar effort, there are plans to, of course, go into Mars after that. Next chart, please. So here is a chart that I think I actually showed last time. I'll just go over it again because it's such a great chart. Artemis One launch date is moved out a little bit from March to August, but okay, we're coming along. Artemis 2, as I showed, they're ready for launch in 2024. You see the human lander system, option A, which is got an uncrewed demo and then meets the Artemis 3 crew in lunar orbit in 2025. Critical on the path as well are new spacesuits, EVA suits that we've got on board the space station. I hate to tell you how old they are. As a space shuttle program manager, I used to own those spacesuits. When we retired the space shuttle program, we were happy to turn over to the following program 13 space shuttle main engines, and not 16. Quite as many as that, 16, I'm 16. Sorry, and about 13 EVA suits. And they are showing their age, and they are not suited for mobility on the surface of the moon. So NASA has let contracts to 2 companies to develop new EVA suits, and that to our lunar landing. You also see the gateway, the power and propulsion element, which is a solar electric propulsion element, and the habitation and logistics outpost, which is a cabin, if you want to think about it that way. Ready for launch late 24. They spiral out to the moon, and then a little bit later, there is a larger habitation module called the IHAB, which is ready for launch, that goes up on Artemis 4 and assembles the gateway. And then life proceeds, and you can see all the development that's going on out there. And the Spree module is being developed by the Europeans. The second lunar lander, the LETS capability, a lunar transport vehicle on the moon, logistics, and so forth following that. So it's quite an ambitious development schedule. Next slide, please. Switching back to Artemis One, I apologize for being a little choppy here. I wanted to just say we had a great review of the science. There are a number of science payloads that are inside the Orion pressurized module that they're taking, radiation and different biological experiments that are going on board this Artemis One payload. And I guess it's all buttoned up. I read that the hatch is closed with light.
Yeah, we'll reopen it back up.
Oh, okay. Okay. Next slide, please. And then on the outside, we have a number of CubeSats and other scientific instruments that are going to take advantage of the time around the moon to gather science data. So we're doing some heliophysics, some again looking for lunar ice, more thoroughly mapping and so forth. So there's quite a large number of scientific experiments on Artemis One. Next slide, please. And again, some of the CubeSats. I really like the Near-Earth Asteroid Scout. That's going to be a very interesting experiment. So we've got a number of things going on the science on Artemis One, even though it's uncrewed, and largely an engineering development flight. Next slide, please.
Wayne, could you perhaps for our edification, the science payloads, and maybe somebody else needs to answer, the science payloads that are going to be on Artemis One, were they chosen strictly for the specific science requirements that are needed at this particular time, or were they chosen based on availability of those particulars?
Yeah, I don't have insight into how they were selected. I know there is a process going forward to select science payloads for future missions, based on scientific needs. But I can't really
It's okay.
tell you how these guys.
General Lyles, if I may jump in here, because I was the deputy AA during the time that decision was made. We chose to put these missions in place, taking advantage of some volume in the interstage. And it was really more of an open call that was put out to the science community and to, at the time, our advanced technology community to allow them to provide input. And then there was a selection criteria established, and then the team went with those in a competitive process based on volume available, interface requirements, and other things at the time. And that makes sense. That was the concept.
Yeah, thank you.
Taking advantage of the ride, basically, that was there.
That's exactly it. We were taking advantage of an opportunity, not using that opportunity to drive the mission.
Gotcha.
So next slide has got a lot of details about the Artemis One flight. I would just tell you that my understanding is the duration of time spent in lunar space. It depends a little bit about the exact launch time and date. And I don't completely understand all of that. I know it's got to do with power generation and so forth and landing opportunities. So the flight, as this chart says, can be 26 to 42 days long, depending on conditions once they're launched. It's launched on the core stage of the SLS. They're using the small United Launch Alliance provided interim cryopropulsion stage is the second stage, and then it utilizes the Orion propulsion system as well, and goes into what we used to call the distant retrograde orbit, DRO, around the moon, which was an early option that was considered for human space flight. It's got some advantages, and it lingers in. It's a fairly stable orbit. But it is a high orbit, not low. And I would just point out that one of the differences between the Orion and the Apollo missions is in the propulsive capability of the service module. If you go back in history, the Apollo service module was specified and designed when the Apollo missions were direct lunar ascent. In other words, they envisioned a much bigger rocket than a Saturn V landing the entire stack on the moon. And then the Apollo service module had enough propulsive capability to lift off directly from the moon and come back to the Earth. Subsequently, NASA elected to do lunar orbit rendezvous, and that wasn't really required anymore, but the design was already potted, so it had a lot of capability. The Orion service module grew out of the old Constellation program when a very large lunar lander was specified, and a lot of the propulsive capability was put in that lunar lander. The Orion service module does not have the propulsive capability to take Orion to low lunar orbit like Apollo did. It must stay in a high lunar orbit, which is less propulsive required. So that's why you're going to see the Orion in some of these very interesting orbits. It has to stay fairly high. So for this particular flight, the first test flight, doesn't really matter. Again, one of the major objectives is that entry and the heat shield demonstration coming back. So that's what we're going to see August, September. I'm sure the weather's going to be good on the 29th. I've already got my lucky weather tie from shuttle days. So, okay. Next slide, please. Going on to Artemis 2 will be the first crewed test flight. And this flight will not go into lunar orbit. It will be a circumlunar flyby. So the crew will have to take their pictures fairly quickly. They will, I think, set the distance record for the crew being farthest away from the Earth, because they'll actually go farther than the Apollo astronauts by some amount. And there's quite a number of engineering demonstrations. Again, making sure this works right for the crew is highly important. Following that would be Artemis 3 on the next slide, which will be the first lunar landing, crew lunar landing, 2 people to the south pole of the moon. And the orbit there, the near rectilinear halo orbit. I just love orbital mechanics. We'll have a class. I didn't include it in the package, but I've got a visual graphic that shows you how this works. This is so neat, so neat. In that from the Earth, it just looks like we can always see the crew in that NHRO orbit. It's like looking at the front of a clock where the crew goes around. But it's got a low point and a very high point. And the SpaceX developed HLS lander will rendezvous with Orion in that distant retrograde orbit. I mean, near rectilinear halo orbit, pardon me, and then proceed with 2 of the 4 crew to the surface. And that orbit is a 6-day orbit. So 6 days later, they launch and come back and meet the Orion capsule, which returns to the Earth. So it's a very interesting first mission. Again, for the longer term, NASA wants to have longer stays, 4 crew, other kinds of requirements. So this is the demonstration with an early kind of lander. Let's go to the next slide, I think. Okay, so this kind of puts the whole campaign in perspective. Again, notional, but I think it gives you an idea of what's going on. So on the left, we're still in low Earth orbit. We still have the commercial cargo and crew resupply vehicles. And we are developing this gateway, and gateway does 3 or 4 things for us. Number one, there are more logistics needed to go to the moon than we can carry on any one flight. So there is a cargo element that goes to the gateway and delivers things like spacesuits and things that there isn't a lot of mass capability for. It provides a rally point there. It's a safe haven. It's got the NASA docking system, the international, supply, so we can take all kinds of vehicles there. And it also provides a platform for science because it remains in this cislunar orbit permanently. And it also provides a capability to practice deep space human operations, which will be vitally important to go to Mars. So it is the progenitor of that transit hab that goes to Mars and back someday. So we're going to learn a lot from that gateway, but it's just vitally important for the cislunar operation, again, because Orion can't go low. It's got to have a place to go. At the meantime, not only is NASA developing the human landing system and potentially more than one, is actually they desire more than one, but all kinds of surface habitat, lunar transportation vehicles, and something that I'm very excited about, which is nuclear surface power. If you look at trying to generate solar energy, electricity at the South Pole, because of the sun angles, it can be really kind of tight. So having the capability to efficient surface power is important. STMD, see Jim Ryder down there, is working on nuclear stuff for the agency, and that will be very important. And then, of course, the scientists want to go all over the moon. They don't want to just be limited to one spot. The Apollo missions were limited to what you call near equatorial areas on the near side, and the science missions would like to go all over the moon and to the far side. And of course, everybody's interested in that lunar ice at the South Pole and how we might utilize that to actually enable Mars missions. Yes, Charlie.
You made a comment just now that Orion can't go low. Do you mean it's not a landing vehicle, so we've got to have a lunar? What did you mean by that?
I mean it doesn't. Again, I'm going back to the propulsive capability. To go into a low lunar orbit like the Apollo missions did. I'm trying to remember. It's 50, 60 nautical miles. pardon me, I'm an old guy. I still use nautical miles. I got to get with the program, I guess, but that took a lot of propulsive. You can get into a high lunar orbit with very little delta V propulsive capability, and that's where we are with Orion. So having the capability to have a rally point where we can meet the landers, meet logistics, keep the crew, happy, and a habitation module there is very important in that higher orbit that
You
you've
haven't
got.
asked this question before, but where is Gateway? What?
It's in the near rectilinear halo orbit, right? You're gonna love NHRO. But before the committee ends, I want everybody to be able to say that. And then we'll talk about the mathematics behind it. It's a stable orbit, and it provides a lot of capability to get to all the places on the moon.
It is interesting when you get a chance for the NASA architects, the orbital architects to listen to Marshall when he was here to explain the rationale for the near rectilinear halo orbit and all the options they looked at, et cetera. It makes sense from an engineering perspective when you get a chance to do that. So it might be something we want to expose to people at some point.
Oh, hey, how late can you stay tonight?
Well, not today.
Okay, we'll be happy. Okay. So, but there's a suite of development programs that are going to go on to support the lunar operation that then morph into Mars capabilities. So if we have fission surface power on the moon, we can certainly have the same kind of thing at Mars. If you want to have transportation vehicles on the moon, they can provide at least a first order capability for Mars. Okay. So there's a lot to be gained, and there's a lot of development work to be done. Okay. So we had a very nice presentation on how we're going to go from the moon to Mars. Kathy Kerner gave us a great presentation on how they're going to take this from the moon to the Mars. And that's very important because I think in the public mind, and I think in the agency, there's a lot of interest in going on to Mars. And certainly it's something that Congress is very interested in. So there's a plan, but what there is not a plan for right now is how do we not just walk away from the infrastructure and capability that we put on the moon. So the recommendation here is that NASA should kick off a study how to transition sustaining lunar activities to other entities following successful Artemis missions and which have established long-duration lunar capabilities. And similarly to what NASA is doing for low Earth orbit and the commercial LEO development, there needs to be a plan to say, okay, we need these capabilities at the moon for a variety of reasons, and probably commercial reasons. And so NASA should figure out how to move on without abandoning lunar capability, because that lunar capability will be very important, at least from the in situ space resource utilization for a long time. So recommendation is to start that planning, and it's early on, so that shouldn't be a big problem.
Wayne, when you say transition to other entities, that could be commercial,
Commercial,
could even be international. a
could be
partner.
international, could be other government agencies. I don't know. Does the Geologic Survey want to have an outpost? It could be any number of things, and we're not specifying. But okay, when we've done what we're going to do with Artemis, we've got this tremendous infrastructure and capability that's been laid in, and we're ready to take the knowledge that we've learned and go on to Mars. We don't want lunar work to cease.
Yeah, so in that light, the term sustained lunar presence does not necessarily imply sustained NASA lunar presence. It could be human lunar presence.
And it may involve NASA. I don't know,
Yeah,
but
yeah.
but the transition needs to be studied because unfortunately, history says that it's unlikely NASA will get enough resources to keep doing the one thing and do the next thing.
Yeah.
So I don't know, maybe Congress will be more generous in the next
We
decade.
we
but
could
we'll
only
find
hope,
out.
yes.
Okay, next recommendation. There was an organization inside Hale that was called the Advanced Exploration Systems. That organization has been dissolved, and we're looking at, as a committee, all the development work on all these systems that has got to be done. And our recommendation, again, for Jim Free, is that you may want to consider reconstituting the AES organization so that you have an integrated look across all the development, all those lunar, transportation and so on and so forth. So again, it's a consideration for the organization. Next slide, please. Plan for lunar sustainability. We got a lot for the first, one slide on what we're doing at the moon. But for lunar sustainability, we're going to need a more fleshed out plan past Artemis 5 or 6. And so our recommendation, and I think it's probably already in work if I don't miss my guess, is how to flesh this out for sustained lunar development, develop a plan. Okay. And as we said, the briefings that we've gotten just go through about Artemis 5, and that doesn't really show the sustainment. So we'd like to see the plan. Next slide. Lunar resource exploration. We've got the Viper going to the Viper is volatile. I can't remember what Viper. It's a lander that's looking for lunar ice going to the South Pole, but it's a one-off. And we believe that there are fruitful areas where looking for lunar resources could provide great benefits. So we think that you should have an office, an organizational responsibility to plan for lunar resource exploration. This comes out of Dr. Sowers and his, this is like prospecting to find good stuff there. And so we think it would be worthwhile to establish an office that thinks about how to do that. Next slide, please. And then we have two findings. I'm not going to read this one to you. It's just that we find that the two directorates of partnership are working extremely well. I mentioned this before. Kudos to Jim and Kathy and their organizations. There's not any turf fights or sandboxes going on that we've seen. An excellent use of international and commercial partnerships and so forth. Just basically, you're doing a good job, and we wanted to recognize that. And the last slide, the next slide's the last slide. We had a discussion about Earth analogs for lunar and Mars exploration. Nancy Ann Budin worked for many years on analogs, and she provided a list for us of lessons learned from those early days of looking at Earth analogs for exploration, and wanted to provide that to the AAs and also to Thomas Zervukan. So there is a large library history of lessons learned from, I don't know if you're familiar with desert rats and sending people out to try out, spacesuits at Meteor Crater and this kind of thing. I don't want to make it sound too silly, but there is a long history there. And in the discussion we had in a joint committee indicated that maybe some folks weren't aware of that. So we just wanted to provide, Nancy Ann wanted to provide that list. So there it is, 4 recommendations for the AA and 2 findings. And we think the future is bright. There's a lot of good work going on. It's difficult work. It's a complex program. There's a lot of development that's going to happen in the next few years to make it successful.
For your Monday, it's National Day of Encouragement and also Video Games Day. And that's the way space is today. Until tomorrow, add an explorata toward the unknown in the measureless arena of space. Stay tough and competent. Thanks for watching.